Hi, so I'm Rohit Jain, work for Mentor Graphics. I am a development manager for Questa Simulator. I have about 15 years experience in the EDA industry. So I'm going to talk about the paper here at DVCon 2015. This paper basically talks about a specific type of the design where your design takes a substantial amount of time in an initial phase. That could be a common setup phase. Now this common setup phase could be different based on a different designs. It could be a PHY controller or a DRAM initialization. It could be a configuration, register configuration, anything that is very common to your regression. So the idea is you are doing the same simulation over and over again for each of your individual tests. So what we're trying to do here in this paper is trying to provide a methodology where you could save those common setup phase, do it once and reuse it for all your tests. So this is based on a checkpoint save, checkpoint restore technique which all the simulators provides. This paper here has examples given for the Questa sim, but you could essentially do the same thing with all the industry's simulators. So some of the things in this paper are we have done, so the basic things has already been there in the simulators. This paper has more features addition and providing a methodology on how you can use in your complex environment. So I'm just going to start here with, this is a methodology. What you do is you start and elaborate your design, run it till your checkpoint point and save the checkpoint state, restore your checkpoint state, and then basically apply the different test stimulus based on how your tests are varying. I'll talk a little bit more about that later. And basically apply the different stimulus, run the test from the same checkpoint state, and then you repeat the same thing. This gives you a lot of advantage in your regression throughput. Couple of examples here are, so this is how you basically do a basic checkpoint here. You run a design and you basically checkpoint it and you restore it from a static time. The examples here are for the static checkpoint and the dynamic checkpoint. And then after the restore, there are different examples here which based on how your design tests are configured, maybe you have a different sequence generator in your test that you want to pick up. Maybe you have a different stimulus file that you want to pick up. Maybe you have a different, the override variables that you want to do. So there are different mechanisms in here which you can apply. One of the feature we have added in the tool recently. So I mentioned like this feature has been there already for a while, but a lot of people or the users does not know how to use it, or they don't know how to apply it in their design. So one of the hurdles we have seen is whenever user has a C code or like a DPI code or an IP model, it creates a bottleneck in the flow. So we tried to provide a way how you could basically modify or review your C code and make it such that it works with the checkpoint and restore flow mentioned here. So the Questa sim provides some of the hooks that you can add in your code, which does automatically checkpoint the related thing and the restore them. There are two things to look for in the C code. All the memory that you're doing from new, delete, malloc free has to go through the simulators simulators API, because simulator needs to know how to checkpoint and where to checkpoint and restore it. So we do it automatically for C code. We provide APIs for the C code. And the second thing is you could have a local variables or a state in your C code that you want to checkpoint and restore. And for that we provide the APIs. So you can, we provide basically the API hooks, and you can basically do whatever you want to checkpoint and restore based on it. So and then there are a lot more details in the paper which talks about all these different examples on how you can, after you, so a lot of times the user has a question that when I checkpoint it and when I restore it, how do I change or run the different tests? How do I change the stimulus? So we have provided a couple of examples which we have seen very commonly used in the designs. It works with all kind of SDL. You could have a system Verilog, VSDL. It works with the UVM very well. It does not work with the randomization, although you could change the randomization just after the elaboration, but not after the runtime. Here is an example in the bottom here that we have taken from an actual user real design. So this talks about, like, if you have a test, let's say 1,000 tests, which you're running in parallel on grid, and each test takes about 20% of the time in your common initial phase, and you're basically doing same common initial phase for each test over and over again. If you use this methodology, you basically do that thing only once, and then you run it only once, checkpoint it, and then you restart all your tests from your checkpointed state. So in a sense, you can actually shrink down your overall regression throughput by the amount of the time your initial common set of phase takes in your test. Now, the gains of how much throughput you're getting, it could vary based on how much the common set of phase takes in your test. It could be anywhere from, say, 20% to 50 or 60%. So based on how your design behaves, it could basically add to that much of throughput. Another use of this flow we have found is for debugging. So let's say you want to run it. Your test takes 4 hours to run, and to reach to a point where you actually want to start debugging, and you don't want to restart that process every time to reach to that state. So you could basically use this checkpoint methodology to save the checkpoint after that 4-hour point, and then from there you start debugging. So it could be very helpful in trying to make the debug process faster. I think that is all I would like to talk about this paper. There are a lot more details in the paper at DBCon site. You can take a look at. You have my contact in there. So if you have any questions, feel free to email you, and I will be happy to answer it for you. Thank you.